Welcome to today's webinar brought to you by NetApp Instacluster, Awarescape, and Hydraulics. I'm Stephen Fegg, Director of Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Modern Data Architecture and Practice, What's Actually Working in 2026. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Bassam Shaheen, Principal Consultant at NetApp Instacluster, Paul Watson-Gover, Senior Solutions Architect at Awarescape, and Michael Cookie, Chief Marketing Officer at Hydraulics. Each speaker today is going to deliver a brief presentation, and then we're going to dive into a group discussion. So without further ado, I'm going to pass the event over to our first speaker to kick things off. Welcome to the broadcast, Bassam.
Thank you very much for that introduction. I really appreciate it, and welcome everyone today. And so looking forward to talking to you a bit about this discussion, and look forward to any questions you may have later on. Covering the topic of data architecture, we have multiple areas we can focus on. We can look at the ingestion, how we store the data, how do we process it, and then how is the data being used. And for each of those areas, there are different tools that can be leveraged. And at NetApp Instacluster, we have been using some tools that are open source, and we wanted to share those with you in terms of how anybody can use the free software and to be able to help with getting the best out of your data. And of course, with nowadays the main topic of AI, in terms of how do you leverage your data for AI data processing. With that, we'll start off with a few slides. So the current challenge with AI is that you have a large amount of data that you need to process for training and for looking up. And you need to have that in real time. You're building your model. You've developed your model. Now you need to get the data access, also integrated with other systems together. This data can be text files, can be PDFs, it can be videos, it can be audio. You want to be able to have this structured and unstructured or even semi-structured data that you're going to need to access, and different ways of being able to annotate what this data is and whether it's relevant to your searches, and which is where the introduction of vector searches against your data that really helps with the AI applications in terms of matching, and all this to be done in a very short period of time, sub-second or sub-millisecond latencies in some cases. So with that, looking at different tools, for people who are not unfamiliar with open source software, it is a software that is developed by different communities for specific use of the data. And these products are used by small companies as well as large companies, the likes of Apple and Netflix, and many of the products are sponsored by Google and Facebook. So these are reliable products that with the best of breed, and we've identified different ones for the data uses. So because not every single piece of data is the same, how it's used, what you want to do with it. As you probably know, in the last few years, you've had this idea that you take all your data and put it in the data lake or in the cloud, and then you try to get access to it, and that worked for a short while, but then it didn't last long. So we look at different ways of organizing your data with the right tools. So, for example, we have OpenSearch, which we're able to store vector data. This is great for analytical data for lookup for RAG. Postgres, if you're looking for a transactional database, it has the capabilities of with pgvector to do AI embeddings and searches on vector data for really quick lookup inference data. Redis, also Valky, which is the pure open source version of Redis, Valky. And it's not only data storage, but also for data processing. So, for example, it's like the likes of the Apache Kafka to manage the pipeline of your data coming in and being processed by the different components, and then going out to the LLMs. That would makes it feasible. And all this is open source data, which is free for use. Cassandra is another product we use heavily. Been using it since it's our base product that we've used at NetApp InstaCluster back from 2012. Again, pure open source free software that we use for a very high rates, NoSQL database, and all these products are able to handle vector data and the data processing for AI requirements. So we categorize the type of data being used for AI ML. You have the RAG, the retrieval augmented generation. This is where you have a specific set of data that a corporation may have that is not necessarily public, available information through the LLMs. You can augment whatever you have coming in from the LLMs with the data that you retrieve from the RAG stores by doing vector searches and merging the two sets of data, so it becomes specific to your company's data, as well as merging it with industry standards. Once you have a proper model and you have the data ready and extracted through RAG or other means, making it available in real time using cache. So Redis is a great cache where it will help with inference of data models. And the third category we look at is the semantic search. So we have ways of looking at the data, whether it is just vector data, looking at text, natural language searches, or if you're searching videos, I want a video that has a red car in it. And so you're trying to find links between the different types of data in a multimodal search that will bring back results that are needed by the customers. The other vector database we talked about briefly is Open Postgres SQL, which has vector data storage as well as traditional SQL relational database. And the open search capabilities with nearest neighbor has augmented RAG data extractions, integrates with different data sources. One of the biggest growth market for us at NetApp InstaCluster right now. Again, this product is free to download and use. And so with the different components, with the data architecture, we look at what exactly we want to do with the data and try to build a system that uses the one or more of these open data tools, open source data tools, that at the end of the day, it will meet your pipeline requirements from the point of processing data, reviewing data, storing it, retrieving it, linking it with AI model searches, and delivering it through a cache mechanism. And specifically, what we looked also in those tools is how already are they for AI workloads. So we're looking for tools that are secure, whether through SOC or PCI compliance, the tools that can leverage fast processors, fast GPUs, that are able to be resilient, whether it's geographical distances between the data nodes, or whether they're both in the cloud, on-prem, or hybrid. Make sure that data, wherever the data is, we can still access and serve it to customers. As well as it's important for it to be scalable and reliable. Without that, we'd be doomed. So, and also, in addition to that, how well can the products integrate with existing LLMs? Being able to LLMs leverage the products so we can have a coherent solution where you're looking at both data coming in from the data models as well as your RAG systems. So, provided here is the different phases we have, whether through the data preparation or testing or inference or going to production. We use pure open source tools. Cadence is our tool that we commonly use for a workflow. It is an open source product initially developed by Uber, but and currently used by DoorDash and others to manage the orders. So why not managing your AI pipeline? Commonly used for the use of Kafka for keeping track of events and triggering different data load requirements, and then a bevy of different open source solutions for your data storage, depending on what you want to use. And so all this is pure open source and no need for dependency on other tools or limited, depending on your use case. It may be limited. So NetApp Insta Cluster has been doing this for since 2012, looking at open source solutions. We provide been testing these products as well, providing them as a managed service for people who need it, or as a consulting support basis. So for individuals who are not quite familiar with these products and looking for somebody that can call 24/7, we provide that help. But we'll be available to ask any questions you have about these tools. Thank you very much, and I'll pass it on to Paul from Wordscape.
Thank you very much. Seem to have gone out of shot here. Okay, yeah, this is it's me, Paul Watson-Gover, Senior Solutions Architect for Wordscape. Here to talk to you about our software and what we do. We are a data warehouse automation tool. This slide here gives a handy definition of what data warehouse automation is all about. And essentially, what we're focused on is bringing automation primarily to code generation. But it's about more than that, because obviously there are elements of design, documentation, which including things like governance and so on, that can really help with AI initiatives that you're looking to embed into your data warehouse projects. Today's risks and challenges. Well, these are today's risks and challenges. They're yesterday's risks and challenges, and probably going to be tomorrow's risks and challenges. This is why we exist in this space. Now, whether they are the day after tomorrow's risks and challenges, who knows? With the advent of AI, things are changing rapidly. They might not be. But this is pretty common. I've been doing this, been in this industry for over 20 years now. I still see these every day, even now. There's not anything really new. There are obviously people who have figured this stuff out and do a better job, but there are still a lot of companies hitting these exact same challenges, and that's where we're there to help. So what do we do? Well, we provide software that helps people address those risks and challenges that they're facing in their data warehouse projects. The primary thing being this first point here, eliminating time-consuming manual coding and reducing errors through providing a consistent template-based approach for your modeling and your code generation. We want to accelerate people's data warehouse projects and have them delivering value to the business as quickly as possible. This ultimately is what makes any data warehouse initiative a success. The failures are the ones that don't actually deliver anything, and the business users are not kept happy. This is where we operate within just purely within the data warehouse space. We do this with two tools. We have 3D, which is a design tool, and then we have Red, which is our build tool. Now, it doesn't matter what kind of architecture you're looking to build or where you're looking to build it. It doesn't matter if it's cloud, hybrid, if you're building data lakehouse, data vaults, dimensional models, wherever you're looking to build, we can bring some automation and structure to that whole process so you can get the data out to your end users on the far right-hand side of this picture. The whole thing is underpinned by metadata, and that allows us to do things like provide areas in the software for you to add documentation for governance or context for future AI initiatives. It also means that everything is just fully documented all the time. It's part of the process. It's not a separate process for us. We do also provide orchestration across the whole piece as well, all the way from left to right. So you can build up these processes, or even including some of the modeling aspects. You can automate those and schedule those, push those models across, generate the code, push the data through the platform that you're using. We support a wide range of database platforms. Everything that we do is native. There is no such thing as Wordscape code. So who can benefit from this? Well, in truth, it's anyone across the enterprise that's looking to use data to help them drive decisions, which ultimately is what any data warehouse project should be about. It's obviously the primary beneficiaries are the data engineers, like myself, and I've been in the past. Using automation tools allows you to focus on the bits that really add value to any data warehouse, which is understanding and then programming business rules, calculations, that kind of thing. And obviously then being able to deliver quickly benefits the rest of the business, in particular the people that are paying for these initiatives. It's always good to keep them happy, so they keep sending more money your way and keep these projects going and keep you in a job. But it's, as you also see on this slide, people like DBAs, because it gives them some consistency as well and understanding of the structures that are being built. Right through to the end users, where you're providing them with exactly what they need as quickly as possible before their requirements change again, which of course they inevitably will. Oh, not on PowerPoint here, are we? So if that has at all piqued your interest, by all means go to the website and get in touch to find out more. And I will now hand over to Michael.
So much, Paul. Appreciate it. So interesting segues today. We talked about kind of the open source architecture. We talked about needing to automate to drive scale across the data layer. What I'm here to talk about is as you take these next generation applications and agentic and AI workflows out to the public internet and deliver it to your end user in production, it adds a whole new layer of scale and a whole bunch more technical challenge get layer on top of that. So I'll just get to it, and I'm looking forward to the Q&A section as well. I've talked about applications for decades, and the last innovation that reminds me of the AI innovations that we were just alluding to was the transition to microservices. And Netflix and Amazon are really famous for microservice architectures that go into the hundreds, the thousands. So these are piece parts of your application that have to be running, and they interact with each other, and there's dependencies across them. And so one of the first big data problems for keeping applications running, scaling them, managing this level of data was being able to manage this huge scale of traffic coming from all these microservices. Now we're going to add to that AI workloads and agentic workloads, and so that's only getting worse. I work at Hydraulics. we were actually born on the public internet. And so our technology was tackling the data problems that come from the two underlying networks underneath those microservices. We refer to them as content delivery networks. But some of the largest have hundreds of thousands of mini data centers that are placed all around the globe. And they take your applications and your AI workloads and they distribute them around the globe so they run quickly and so end users have a great experience with them. You get the idea. You've got thousands of parts to your primary application. You're changing the primary application thousands of times a day. Amazon is the stat down on the bottom, 23,000 deploys a day, millions of changes being made to their applications every year. And then you're deploying it across hundreds and thousands of nodes or points of presence to get it distributed across the internet. And so you end up with this exponential problem. And the technologies we've talked about today, the AI solutions and the agentic workloads and even automation is going to generate more and more telemetry that we have to manage so that we can keep this stuff running smoothly and we can keep it secure. And happily, the three of us all kind of agree on the challenges, but I think they really do change as you start thinking about global scale. And a lot of what Bassem laid out is a perfect reference architecture, but as you move into production, scale it across the global internet and start to lean on it as the primary way to do business and your primary differentiator, it starts to get hard to manage, it starts to get expensive, and really like physics sets in where it actually starts to slow down in terms of performance. So you've got billions of events occurring, hundreds and thousands of parts to your application distributed everywhere. You've got AI work added to that, and these systems and these pipelines and these and this data fabric that we've already talked about today starts to get taxed, whether it's from efficiency or cost, performance, or just straight up complexity to manage. It really does have a high watermark, if you will, where you have to think about best in breed solutions in a way that unlocks you at this level of scale. And so the way that we do that with that open source approach is we start to make sacrifices. We might not keep years worth of data around. We may be happy to keep it a week's worth of data or a month's worth of data, or we'll sample data and we'll just take little independent samples of data instead of the entire thread of data. And we have to make assumptions based on limited data sets, which can really impact AI and analytics results and accuracy. Or you're willing to go really fast, but you can't keep it around, or you're willing to go really fast and spend a ton of money. And all of this is underpinned by the amounts of data, the scale we have to ingest at, and the analytics we want to run across it. And because compression is so hard or so limited these days, that storage cost and that cost to keep it around and analyze it gets super expensive. I think we all agree you want to keep all of the data around if possible. AI, machine learning runs much, much better with larger data sets. You want to be able to query it at all times. You really don't want to put it offline because when you need it, you need to go rehydrate it, and you need to use Paul's product to bring the data back into your primary data store. You need to be able to ingest terabytes daily because of all that traffic I talked about. And to enable that and without breaking the bank, we really need to achieve next generation compression. We solve problems like this at Hydraulics, but when I can just tell you, when you look at that 500,000 network deployed across the globe, that CDN was waiting 30 minutes for telemetry to be collected, brought back over the data pipeline, indexed, put into its data store, and to be able to be queried or build databases, dashboards. It took them 30 minutes. And so their customers were calling customer support and saying, I'm broken. My web property, my streaming is down for all of Mexico. And the provider literally didn't know. So it was a canary in the coal mine. 25 minutes later, they'd say, oh my God, all of Mexico is down, right? And so they had to move this to like seconds and minutes of awareness. And so we implemented some of the technologies I'm about to show you, and we brought 30 minutes down to 5 seconds. And we can do queries across that data in sub-second. And now the company knows when things are breaking instead of waiting for customers to feel that pain and have their brand impacted or their bottom line impacted. And so when I was asked what's working by Steven, I was really happy because we didn't do a dry run. But when I saw Bossam's content, we are saying the same thing. You need to really be able to have a real-time streaming approach. It needs to scale really quickly. You need to be able to do intelligence on that pipeline, and you need to move as much intelligence as possible to the real-time layer. You want to have kind of an open source or an open architecture approach towards that super expensive storage layer. In our case, we used object storage because it's extremely price efficient, but it's also extremely high performance when you use it right. We preach being able to scale ingest separately from analytics, separately from how you're storing that data. We famously helped do observability on the Fox broadcasting of the Super Bowl last year. We had 15 million streams being observed simultaneously. We were doing like a terabyte a second, I think, a petabyte and a half a day. And we were still at dashboards in 5 seconds. We were still querying in sub-seconds, 500 millisecond queries across that. And then we've unlocked some compression approaches that are enabling really long-term retention, but you can still query in that sub-second, real-time fashion across even highly compressed content. And then finally, and I'm really excited to get to the Q&A, that means managing a whole bunch of different telemetry types, being able to instantly scale out and scale back in your intake peers, because that example I just gave, Fox Sports went from 0 to a petabyte and a half a day, and then they don't want to pay for that infrastructure for another month or even another hour than they do. And so being able to scale in and out your intake workload and capacity, super, super important. Then having the ability to process and transform that data in the pipeline, maybe optimize it so it does get stored very, very efficiently so that it is stored in a way that's highly compressible. And in our case, we know that our storage type is columnar. And so if I can store that data efficiently in columns, guess what? It compresses super, super impressively. We also have a proprietary partitioning methodology that lets us spew data into a storage plane that it can be analyzed extremely quickly. But over time, we go back and we merge and we optimize and we make smart decisions about future partitioning methods that move like data sets together into common partitions so that, again, they can be optimized, compressed more effectively, and they can be queried super, super quickly. And then the other place that we scale out and in linearly is the query peers, because some customers need sub-second query on petabytes of data. That takes a lot of horsepower. Other customers don't. And you want to be able to take these knobs and tweak them as you go. The last thing I'll say is that one of the reasons I joined Hydraulics actually is I've been doing data science and data architecture for 25 plus years, but we are kind of independent of your primary interface. This is kind of like what Paul was talking about. If you're a Grafana user, a Splunk user, a Databricks user, a Datadog user, we don't care. We're not trying to take over your primary workflow. We're trying to unlock the storage challenges that were keeping you from doing all the things you knew you should be doing, making sacrifices about how much data you keep, allowing yourself to fall 30 minutes behind your customer experience. So we like to plug directly in and then allow all the common query types to run so you don't have to relearn how to explore data. So with that, I just got the red signal, but guess what? I'm right on time, thanks to my co-presenters. And let me hand off to Steven and let's get to some Q&A. Thanks for the time, everybody. If you want more information, by the way, it's hydraulics.io on the website. And actually, we have a great blog post that talks all about this storage approach and our compression approaches if you like to dive deep on speeds and feeds. So thanks for the time. Looking forward to the Q&A.
Okay, thank you very much, Michael, and great presentations, everyone. So it is time for us to get down to brass tacks with our group discussion. And normally I start these out by asking each of you to weigh in on what do you think the top challenge is, but I thought I might change it up here. Of course, hindsight is 2020, but I thought we might get some interesting takes with this question. So, Bassam, I'm going to start off with you. I know it's a lot of pressure. You're going to be our leadoff hitter here. What advice about modern data architecture from just a few years ago is at this point outdated or simply wrong?
Yeah, I think I hit that on that a bit in my presentation. Is that a few years back it was the cloud was the panacea. You take all your data and put it in a data lake, put it in the cloud, get everything there. What tools are you going to use to extract data? We'll figure it out. And yeah, it's one database, but we're going to go with that, and that's going to be it. And that we found quite quickly that does not really meet the needs for customers. And you have to look at what is the use of the data that they wish to have, and then pick the right solution for them, whether it is for analytics or whether it is for transactional, and limited to a limited set of tools that will meet the needs. And that's what we currently see as being the case. In addition to that is to also have in consideration the hybrid approach, that the cloud is great. A single cloud is good. A multi-cloud is better. So you distribute across different hyperscalers as well as on premises. So where some data needs to be on-prem. So not including those environments was a mistake, and I'm glad that we're seeing a shift in that.
Understood. Paul, what is your take on this? Do you agree with Bassam, or do you have a different piece of advice that you think is pretty much outdated at this point?
No, it's basically the same answer as Bassam. I mean, when I think of this, I think of the whole big data hype thing that came along, and Hadoop and the likes that said, people saying, "Oh, you don't need a data warehouse anymore. You don't need to structure your data anymore. You just dump it all in Hadoop, and you'll be able to just read it. Schema on read, I think it was called, and that all proved to just be unequivocally rubbish. Because here we still are now, still building data warehouses, still structuring our data in a way that's easy for consumers to understand, right? So nothing's actually changed. There are a few different terminologies thrown around now, but essentially we're doing the same thing still. That might change in the future, but as I said earlier, but right now, no, we're still in the same place.
Fundamentals are still there. Michael, I saw you nodding. Where do you stand on this?
I agree, but I've been watching decades of patterns. By the way, I was at a Hadoop vendor, Paul, so believe me, I lived that as well. We've been in. If you look at a macro level, if you talk to analysts in the space, they're looking at 5-year increments of transition. I would say the big win in the past 5 or 10 is that people have accepted data is really important. Then they thought, let's put it all together, and they realized, oh no, that's not technically working very well. And so it remained relatively siloed. Data pipelines have come around now. That's a nice, intelligent layer that's kind of giving us some connectivity across things, giving us some intelligence there. But those aren't new either. Like we had ETL 10 years ago, 15, 20 years ago. So what I will say is interesting to me is that I think we're at the point where everybody knows that all the data is important to everyone. There was a world where security people thought that they should keep some data, and observability people thought they should keep some data. Everybody's kind of agreeing we need the source of truth data around to be accessed. And then I think both Paul and Bassam nailed it, which is like the platform vendors. I feel like we're in almost the end of a kind of dark phase that I call platform vendor. And I don't mean NetApp, by the way, Bassam, but the worlds of like security, threat detection vendors and observability vendors have come together. They understand they need it all in one place, but now they're trying to sell good enough to their customer base. And I think you just heard really clearly, like we all exist because one platform stack is not right for every situation. And so I think we're heading to something that people have talked about, but has never really manifested, which is a true data fabric, which is something where you need Paul's technology to automate between the systems, and you need Bassam's technology behind it, potentially different types of storage layers from NetApp, and then you need different kind of query layers and different index layers for each use case, whether it's transactional or operational or analytical workload.
Those are some great points there, Michael. All right, since you went last on that question, I'm going to let you kick off our next one. And I guess I'll preface this next question. Obviously, it's going to depend on the company, but in your opinion, based on what you're seeing when you're interacting with your customers and your prospects, when one comes up to you and says that we want a modern data platform, what problem are they actually trying to solve underneath the buzzwords, perhaps most commonly?
I'll quickly say I think it's inside of those sacrifices that I think we all talked about, that, but I talked about, where people are sampling, people are offlining, cold storage, they're doing tiering of data, they're only keeping certain amounts of data. I'll give a few examples. Endpoint security data is similar to agentic data we're going to all have to tackle in the next 3 to 4 years. Inside the world's best, most advanced security stacks, which are doing XDR or endpoint security, they can only afford to keep 7 days worth of data around. In the world of bot defense and monitoring bot traffic, which is soon to be agentic AI traffic across your websites, across your web properties, they only keep 30 days of data. I talked to a major customer, a brand that you would all know, but they were using and I won't name the vendor, they were using a standard observability stack, and they were sampling every 5 minutes, and they were having outages at sub 5 minute intervals. And these are the things where when they say modern data platform, what they mean is I got to be able to do better than this. I'm currently vulnerable. My business is at risk. I'm spending a ton of money, and I'm still worried. I'm still anxious. I'm still not serving my customer, or I'm leaving my business at risk. So I feel like that term is just, please, somebody figure this out for me, basically.
Yeah, no, that makes a lot of sense, and perhaps it's overused. It's a very popular term these days, and everyone kind of wants to be a platform. We've kind of moved towards a lot of platform centric thinking. Bassam, where are you on this?
Yeah.
What do you see beneath the buzzwords when you're talking to clients?
It has probably not changed a lot. It's just different phrasing of it. So really what customers want to have insight on their data, not just spend the time building the systems, trying to find out what is there, but actually to get true insight in a way that is cost efficient, not too expensive, and throwing money at just a large amounts of data. We need, as Michael mentioned, picking the right amount of data, not more than is needed, to be able to process that and deliver it in a very quick period of time. That is key to customers. It is cheap, quick, and insightful, and that's what we try to help them with. So that's my short answer.
It's a short and sweet, absolutely. Paul, what are your thoughts on this?
Well, if I can, be the slightly cynical British guy just for a minute.
I love it. Go ahead.
I have to say, often I'm not sure they necessarily want or need a modern data platform. If I can copy Michael there. Often they've just been sold one, right? They've been sold the fact that they need this thing, whatever it is, right? And often you find that people don't need a lot of the things that they're sold, in all honesty. And what they should be focusing on is, what does the business really need? Do I need this thing? Now, if I answer more correctly, it'd be agreeing with the other guys. What they want when they talk about a modern data platform is something that's safe, secure, responsive, looks after their data and enables them to answer the questions they need as quickly as possible. Right. So I think that is what they want. But yeah, my cynical point still stands a little bit.
Yeah, no, that's a great point to raise. Sometimes we want things that we don't really need, or we think we need some, but everybody needs the data right now. Well, does every single person at the company need real-time data? There are costs associated with that. So yeah, no, that's a very valid point. And Paul, I'm going to let you kick off our next question here. Again, in your opinion and based on what you're seeing, what architecture pattern are you seeing a lot of success around right now across industries?
Well, from the data warehousing perspective, it's quite difficult because there are a lot of different architecture patterns that people follow, and they go in and out of fashion. So it really the one that you hear most now is this whole medallion architecture thing, uh, bronze, silver, gold, data products, blah blah blah. But again, this isn't actually new stuff. It's just rebranded old stuff. However, so is it something new that people are doing? It's just ever so slightly different to the way they were doing it before, but it's basically the same. And so it's not surprised that people who have been successful in the past being successful with it again.
Yeah, no, you're right to point out that there is quite a bit of recycling or reincarnation, I guess you could say, amongst different concepts in this industry if you look at it over enough time. Michael, where do you stand with this as far as architecture patterns that you're seeing really succeed and driving a lot of interest at the moment?
I guess I totally agree. I'm ready to retire because the circus continues, like it's the same thing as centralized processing and distributed processing and centralized data management, distributed data management. Like there are cycles, and we're still in them. I think, like, to me, what's super interesting is how there's like sea changes of technology that force a rethinking. And like I said, when 10, 15, 20 years ago, when it was a microservice transition, which includes that cloud transition that Boston was talking about, there was a lot of ethereal, like, we're just going to do the same thing. But there also was some new problems, like, developers could, I ran a data center for the federal government. It would be 6 months to a year to deploy a new application or a new database. And I'd have 4 months to do sizing with Oracle to bring the database in, or NetApp to do the storage behind it. And so the days of that like changed. And as of 10 years ago, we all had to assume that a developer, literally a developer, could press a button and deploy an entire data center, potentially in multiple locations globally. That would have scared the heck out of me 25, 30 years ago, when I was responsible for the rack and stack of 400 applications. And so like it not like, I feel cynical and I feel pessimistic about these things as well. But then I look back at decades and I'm like, wow, shit did kind of change. Did the approach change? Did the logic under it change? No, but we actually were forced in production to build the ability to support a new level of velocity, or a new level of flexibility, or a new technology stack. And so I definitely, like, whether we're in an AI bubble or not, the workloads with AI, the processing with AI, the data with AI, the coming agentic automation workflows that are coming, I do think we're going to be forced to potentially take the old logic and the old way of solving problems, but it's a new problem to solve. So I do think we're all going to, like, it's going to be a 2 to 5 year journey here, but we are pushing more into this system, and we'll be forced to make things that we thought were impossible a couple years ago. We're going to have to make them possible. And, again, to Paul's point, that doesn't mean we're going to like invent magic, but it does mean we have to keep grinding to the next stage here.
Absolutely. But Sam, what are your thoughts on this?
Yeah, I like what I hear. But the gray hair here is going to talk a bit. I've been around for a while. I've seen things change back and forth, whether it's dumb terminals to client server to cloud to. But one of the things we learned, consolidating everything in the data lake, there's some benefits of having things in one place, and there's some benefits of having things distributed. So, from a governance point of view, it's good to have things centralized, the labeling and the different requirements there. When it comes down to data solutions, we want to have a custom fit of what is needed. From an observability, having, as Michael had mentioned, it's key to have the metrics to be able to look at where things are sub-second. So that is a great place where you can have things consolidated or at least federated, maybe. So it just kind of at every level that you change the environment, you learn something new, you apply that. So it's a hybrid solution. Again, whether centralized or decentralized, not necessarily it's one or the other. It's a combination, and depending on the component.
Yeah, and very few companies out there are starting from scratch. I mean, there may be some, but anyone that's been in the game a little bit they're going to have legacy stuff. They're going to have baggage, tech debt, etc. So you're absolutely right. I'm going to let you kick off this next one, Bassam. Are operational, analytical, and AI workloads converging onto fewer platforms or separating into more specialized layers? What are you seeing going on?
It's both. So depending on the type of specialized layer that you're looking for, what are the issues that you're seeing? Whether it's a performance bottleneck, secure, high cost is the concern. The operational risk. So if you have everything in one place, what are your risks? If you're working with one provider, do you need to look at having multiple providers in case one is unavailable? So it is really both,
Gotcha.
up and down depending on the situation. Yeah.
Gotcha. Paul, is that what you're seeing as well?
Yeah, I tend to agree, but also I would say that what you see are vendors trying to kind of force that. You look at vendors like Snowflake or Databricks, for example, or Microsoft even, they're trying to get people to bring all that onto their singular platform. Now, the problem with that is, I could name some companies, but I perhaps won't name them, but certain CRM and ERP providers who try to do everything all on one platform. And what happens is not only do they not do most of those other things very well, they start to not do their core thing very well either. Or you just end up with this bloated thing, right, which doesn't really work properly, and everybody complains about it because whenever you talk to anyone, they complain about these tools. So whether or not these more modern tools that are trying to do this consolidation will fall into that same trap, I don't know. They do seem to be of a slightly different breed. They're newer. Maybe they'll get it right. In some respects, it'd be good if they did. But personally, I've always been a fan of really focus on that thing. Be really good at that. I'd rather have
good at the one thing. Yeah.
Yeah, and then the other things that do the other things really, really well. I'm a fan of that approach.
Gotcha. No, kind of best of breed, purpose fit, and yeah, you're not wrong. In general, the vendors love the idea if there's one platform that they can kind of rule them all, get as many people as possible on that. There's certainly a business benefit to that. Absolutely, 100%. Michael, what are your thoughts on this?
Another interesting topic and trend. I think Paul alluded to this a little bit. One thing we did achieve is we got all the data in one place. Now accessing it is where is problematic. AWS, consolidated their security data lake and their CloudWatch data and their observability data. The other thing that happened in the last 5 years is that, and again, it was alluded to, but the clouds all became biased. Like no longer was it AWS, Microsoft, Google independence and choose what you want. Now they have a biased stack that they're trying to sell to their customers. And so in my opinion, we are in the dark days of platform right now. But what's happening, so he mentioned some good ones, Databricks, Snowflake, another one is ClickHouse. They're layering Postgres and SQL access onto things. There's the momentum of the Iceberg API and Iceberg interface, and data structure standardizations. But again, you're hearing it loud and clear here. When you try to use that generic platform for certain use cases, they break, or they're super expensive, or you fail. And so I think, you've got a good panel here because we believe right tool, right problem. And we're not going to take a hammer to every single issue. But when you're trying to become a triple billion-dollar company and you're trying to take as much of the customer's budget as possible, you claim to be all things to that customer, and then you'll figure it out as you go. good example is that a lot of these large platform vendors, a lot of these cloud vendors, they're giving away like the parts of their platform that are just good enough. They'll sell the ELA, the like 3 to 5 year engagement, and they'll just throw in the thing. Like maybe it's log analytics, maybe it's something else, maybe it's analytical queries across the data, and they know in the back of their head that everything takes 10 minutes to run on that, or that they get super expensive over a certain capacity. And so they're kind of steering the customer in a not, I wouldn't say like a completely dishonest, but certainly not a good direction. And in 3 to 5 years, the customer is either going to have had purchased other technology to solve those gaps in addition to the platform, or that platform vendor, if you're hydraulics anyway, we hope that platform vendor's at risk because they overpromised and they failed to deliver on specific things. Like, again, we're not going after the primary data market because I think that a lot of those companies have a great offering in that world. But I know for a fact their platforms have significant technology gaps.
Understood. No, and overpromising, under delivering, that happens in Silicon Valley. That certainly happens in the technology world. And I don't know if I can fault customers or users for wanting to find a one-stop shopping. And if it seems like a really, sometimes things are too good to be true at the end of the day. Michael, you're going to kick off this next one with me. Where do modern data architectures most often fail in production? And what design choice is usually the culprit?
That's a good question. Because now you're forcing me to be a little self-critical here. I think there's a negative return to complexity, right? And so that's why I think like laying out the primary 5 to 10 business critical things you need out of your data platforms or your data layers, and not having sacrifices there is super important. But I do find a lot of customers quickly outgrow or immediately realize that their system is too complex to support in production and at scale. And so, that is a great question. The answer is why we all have jobs and why data architects matter and data structures matter. It's not easy to do these things right. And knowing when a bespoke solution makes sense, it matters. But with that said, I think if you pay attention to your biggest pain points in the areas that you're making business critical sacrifices, like I said, kind of making that top 5, top 10 non-negotiables, that's where I would argue you focus. But as you move to production, as scale goes crazy, the world goes crazy. Like the largest gaming developers and gaming companies in the world, if you build for their average day, you're going to break on their release day, which is usually 400 to 500x, right? And even like running over these CDNs, I remember I worked at one for a while when the new iPhone release would come out. We were panicked for months because even our production system supporting thousands of customers, one noisy customer could have taken the whole entire offering down. So, that question you asked is kind of like you're only as good as your next biggest day, and even the best thought out architectures break under load or under crazy use cases. So I think that's why we all have jobs. I don't think AI is going to replace us quite yet. I think we have a few more years where it takes planning and foresight and also just partnership across the business to flex with the use case that applications are being put under today.
All great points. And yeah, we have a few years where somebody or a number of people will have to mind it, pay attention to what it's doing and making sure it's behaving. But Sam, what do you see as the, most often kind of fail modes with modern data architectures and what's behind that?
Yeah, it was hit upon really understanding the operational complexity. So, and to be able to rein that in as much as possible. You can do further investigations before you start. Try to do the best you can. You may get 80% of what you need to have to fully understand the complexity. But what will help you with the next 20% is building into it the ability to have the gathering of the metadata, metrics to catch things before they break or in plan ahead. If there is growth, make sure that you are able to handle that growth. And so the lack of the visibility in terms of what's happening has been a big source of failure. The not knowing what it needs to be done to handle the complexities is another piece of failure. And then, of course, that all comes down to then your budget. So if you're having to constantly fight fires, trying to throw hardware at things, trying to throw more VMs, whatever it is that you're trying to fix, then your cost becomes higher. So it's just finding minimizing risk and also managing it so that in case it does come up, what do you do?
That makes perfect sense. And I don't know if it's a term that's been said before, but it sounds like you would become modern data architecture poor. Kind of like have somebody could become house poor. Don't worry, I don't think it's going to take off. Paul, where do you stand on this one?
Well, yeah, I agree with both these guys. Really, it's not so much architectures even or technology that fails. It's the human element, right? It's not doing that planning. It's not having that foresight of thinking what's actually going to be done with this system. It might be the architecture ultimately that fails, but that's because you haven't planned properly. I mean, it's a classic human error, right?
That wasn't fair of me. I put it on the architecture, but it's really the people.
Yeah. Ultimately, I mean, one of my favorite examples where they did it right was the Victorians and the London sewer system, where the Victorians built it and thought, you know what, the population's going to increase. Let's build it 10 times bigger than it needs to be. And that's what they did. Now, of course, now we've gone even beyond that, and now it's starting to stress again. But at least they tried to think ahead, right? And that's what you got to do.
About scalability.
It's a different twist on pipeline fragility.
Yeah, exactly.
So we're still dealing with pipeline fragility. So yes.
Okay, Paul, I'm going to let you lead off. This won't be our last question, but we're getting there. I see that our time is getting a little late, but everybody's staying with us too. Thank you, wonderful audience. So, Paul, I'm going to let you lead off this one. Looking back 12 to 18 months after deployment, I guess the inverse of the last question, I asked, what decision do successful teams make early that pays off the most later?
Well, I mean, it is a similar answer. It's almost the same question, I guess. But I think as layered on top of thinking about those things and planning ahead is also setting up your standards and processes early on. And then obviously importantly, following them, because you find that what happens is people allow things to come in, distractions to come in. They stop following their processes. They stop implementing their standards. And then that's when things get messy. And then, you end up deploying and you look back and go, we made these decisions early on to avoid getting in this mess, but we ignored them. And surprise, surprise, we're in a mess. I think that's probably how I would look at it.
Gotcha. You had a great plan. Didn't really follow it though. Absolutely. Michael.
It's those non-negotiables. It's building SLAs. It's avoid lock-in. Do POCs. Like these things matter. Use POCs as business value assessments and performance value assessments. I think all of those things are in addition to what Paul said, but I agree with Paul 100%. Don't mail this in, because in the end, it could be your job or your business that pays the price. These is huge investments that, any digital centered business is going to live or die by this decision. I mean, your competition's going to get it right. You're going to get it wrong, so it's an important decision. Don't make sacrifices, don't cut corners, and don't get locked in.
Absolutely. Bassam, where do you stand on this?
I'll carry on that don't get locked in statement. I've been talking about open source software, and you don't want to have vendor lock-in. You don't want to have to pay more than you need to. I'm sending you on free software today. Open source software is free. Really for those who have only dealt a little bit with it, or are hesitant. Open source software, especially for data products, is quite stable, and recommend a good look at it, because at the end of the day, you'll have a best of breed product that is not going to cause hardships for your company's finances, and supported by a community. In many cases, security on these products are optimal, because you have many people who are using it, that are reporting it, and then others fixing it quickly. So to take that into consideration, surely.
Okay, so I want to make sure we get to some of our attendee questions as well. First question that came in, and I'm going to kind of toss this up, but Sam, you get first crack. Do you foresee that there might be dramatic dev/op differences when we all come to live in the new generation of Manhattan-sized data warehouses that are being built now? Thanks, great presentations. You can pass it on, or weigh in how you see.
I'm looking at, depending on the question, is Manhattan large or Manhattan small? Manhattan is a small island in New
Well, I
York,
guess data. Yeah, I'm assuming.
no, these data centers are huge. I understand. I was just
Yeah.
but maybe the demand for technology is there. If we're looking for certain things that require larger data centers, large architecture, we'll build them as needed. But putting everything in one bucket may not be the best option. But there's comes down to really why everything is in one this large data center. Or sorry, was it data center, or was it what
It
the
was
question
data.
again?
Actually, she said data warehouses. My mind went to data centers too, because I know they're building.
Because
the
someone
size
had
of
something
stadium.
physical. So I think the days of the large data warehouses, everything in one data warehouses, we've seen some of the cracks in that, and there are other solutions that need to be looked at. So there are some benefits for that, but that's not the only solution.
Absolutely, Paul. I'm going to let you take a crack at this.
Sure. I mean, so assuming we are talking about data warehouses, as in having lots and lots of data stored, then I think there could be differences. I mean, if the AI hype turns out to actually be true, then we'll definitely see dramatic differences, because you'll be able to obviously develop and operate those warehouses with AI far more efficiently than you can now with us, silly human people. So, the short answer is yes. There is a potential for extremely dramatic differences in the not too distant future. Whether or not that is going to happen remains to be seen. It's an interesting world we live in at the moment with the AI and all the hype surrounding it, and not knowing how much of it is real and how much of it is just hype.
Yeah, no, that's a very fair point. Michael, anything you'd like to add?
Great question. I scared the hell out of my team just yesterday talking about how AI was changing the DevOps cycle and the CI/CD cycle. And so on one hand, I agree 100%. Like our development team came to the marketing and the go-to-market teams and said, I'm actually at the point where I think I can ship code every day. Claude is coding Claude right now. So like the cycle time is getting crazy. With that said, the industry is still in its infancy. And so like are LLMs prime time? Sure they are. Is enterprise architecture and production enterprise workloads embracing agentic AI today? Not really. Like startups are doing it. We have to think about it. It's coming. but I think that like the ecosystem's not ready yet. And a lot of what they're doing, like a lot of what's not ready, is making it relatively seamless and trustworthy and cost effective to start leaning on to that new stack that is out there. And so I think that, like, if you look at AI and agentic in general, nobody can figure out how to monetize it. And so like even AWS Agent Core, you ask them how much it's going to cost, and they're like, I'm not sure yet. So I agree that there is a big new world out there. But I think that, like, for all of us in enterprise, we need to be building for it, thinking about it, architecting for it. But it's not like you're behind if you're not able to manage it today. I think the industry is going to build a lot of the bridges that will make it more achievable and feel more native, because CI/CD and DevOps has come a long way. And so now that we have those workflows and those people working in that process, we're starting to learn how to build services and cloud workflows that plug into that. And I think AI will start to become a native for a DevOps workflow. And then the last thing I'll say is that we're seeing this is kind of to Paul's point, we are seeing some pretty amazing impacts of AI. We can use AI to look at partitioning and at data structures and actually predict access patterns. In the past, we'd have to wait for the workload to be running, and we'd say, oh shit, we put the wrong amount of cache, or we partitioned this incorrectly or whatever. But now we're getting to the point where we can do smart prototyping with AI and actually use AI to optimize the data structure, optimize the partition, and potentially eventually choose the right part of the data fabric for the workload. So yes, coming. Don't worry, the industry knows that it can't be impossible for you to use it, and then the technology itself is going to hopefully make some of this a lot easier on all of us.
Yeah, it seems like it's on its way. And as far as the massive data centers that are being built, I think a lot of that is, building capacity for anticipated demand, it seems like. So we'll just have to keep watching it. Before we depart, gentlemen, one more quick lightning round. I want to give you the opportunity to offer final remarks. Michael, why don't we start with you? There's one thing you'd like everyone in attendance here today to walk away keeping in mind front and center. What would that be?
Well, first of all, thank you so much, Stephen and Paul Bossum. Like, great chat. I think we all come with very similar perspectives, and so rather than reiterate all the things I think we're dead on today, I guess I'll use this time just to talk about when to think of me and when to think of hydraulics. We are one of those believers in best in breed. We've built a database that is really tailored towards real time. So the stuff that we talked about today, like this is not a database for all things. This is for real time global scale problems. And so when you look at a data fabric and you think this platform can't serve this, or I can't get this done, I don't have enough money to tackle this data challenge, that's a moment to, again, think about a best in breed solution. Hydraulics is here to solve real-time global scale problems. And we're also big believers in you need internet signal in order to deliver, secure, and maintain today's applications. So when it's about stretching from a data center or a cloud out across the internet to millions of users, that's when to think. In my case, that's a corner case you don't want to use a platform for, and that's something that I believe strongly in, and that's what Hydraulics does. But in general, just a great session, and I really agree with a lot of the thought leadership that was on the call today. So listen to this panel and don't get backed into a bad decision.
Fantastic. Paul, your final remarks, words of inspiration.
I'll try. Yeah. Likewise, thanks, guys, for this session. It's been fun. I think it's challenging. So in this time of AI and particularly a lot of hype around AI, I've been resisting it for a long time, but I think actually time is now to embrace it. So don't run from it, embrace it. But for the time being, keep doing what you're doing, because it's hard to know if it's going to be next week, next year, 5 years. If you believe Elon Musk, we're all going to be just sitting on a beach every day by the end of this year, and that's clearly nonsense. So just keep keep doing what you're doing, and but look for new ways to learn some new stuff. Right, embrace this new technology, learn it, understand it a bit, figure out how it can help you do your job better, do more of it. Because that's always been the message for us, at Warescape. It's our tools designed to make you more productive, but the idea there is, well, if I can then use that tool to do the work of 3 people, well, don't fire 2 people. Get those 3 people delivering more value, right? So focus on that approach as best as you can with this technology that's around today.
I like that, and I like that it's pro-human. We're not just going to be hanging out on the streets or the beaches. Awesome. I'm going to let you deliver your final remarks, your last one.
Well, we had some great wise words from both Paul and Michael, and yeah, absolutely. Humans are important. Time changes, work technology changes. I remember back in let's see, what was it, 1993? I read an article about Oracle 8 coming out and saying that in 2 years there won't be any database administrators needed. So yeah,
Oracle said that.
yeah. So Oracle 8. So a great product. Nothing against the product at that time. It was good, but just the idea of how important humans are to keeping this world running. Keep that in mind. Things evolve. NetApp was a storage company. Now it's a smart data company. We're evolving as we need, adopting different data technologies for improving customers what customers need. But at the end of the day, we're always, for me, I'm always looking for the right solution to make lives better for anyone, for myself and for my customers, as well as people around me. So it's a pleasure to be with you on the call today, and look forward to another discussion in the future.
Absolutely, we'll have to get you all back again as things progress and see how we fared as far as our predictions or anticipated outcomes as things move forward. Well, I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Bassam Shaheen, Principal Consultant at NetApp Instacluster, Paul Watson-Gover, Senior Solutions Architect at Warescape, and Michael Cookie, Chief Marketing Officer at Hydraulics. So if you are wonderful attendees who stuck around by and large, despite the fact that we've gone quite over today past the bell, if you would like to review this presentation or share it with a colleague, you can use the same exact URL that you used for today's live event. This will be archived, and you will receive an email once the archive is posted. And as always, if you would like a PDF of the deck, you can go to the handout section once the archive is live. Thank you, everyone, for joining us today, and we hope to see you again soon.